Here I'm going to illustrate how to solve a few sums on integration based on the concepts that I have taught until now. So here's the first sum. It's 1 by x squared multiplied by sine square of 1 by x. How do we solve this question? Well, it's very simple. I mean, all questions are simple if you know how to solve it, but in this case, we take 1 by x. We substitute 1 by x with a variable, any variable we can substitute it with any variable, let's say t. So when we differentiate both of these sides, we get minus 1 by x squared dx is equal to dt. We have 1 by x squared and dx over here. These two expressions will be substituted by dt. So this is what we get. Sine squared of t multiplied by dt. And since we have a negative sign here, not to forget that, we add it. It's a constant, so we just keep it outside of the integration sign. We have switched the variable from x to t now. Now how do I substitute that? How do I integrate this? Now I'm gonna use basic trigonometrical concepts to change sine squared in terms of cos. Sine square of a variable, say t in this case, is 1 minus cos 2t divided by 2. 1 minus cos 2t divided by 2 dt, and there's a negative sign. So this becomes cos 2t divided by 2 minus half dt. You see, because if I bring this negative sign inside the integrational sign, it becomes this. Now we split this integration into two parts. You can see the two parts. This is what it becomes. The cos 2t by 2 dt part comes in one part, and the other one is, since half of the constant stays out, we have dt right here. So now there's a half here as well, so that comes out. We can just integrate it directly. The integration of cos is sine, as you know. And then we differentiate this variable, and we put the value in the denominator. The integration of half dt is half t. So what we have here is 1/4 sine 2t minus half t. Now it must be very clear to you what you have to do now. Oh, I forgot a plus C this time. Never forget the plus C. You can lose marks in your examination for that. The final answer, when we substitute back 1 by x in place of t, is 1 by 4 sine 2 by x minus half of 1 by x plus c.
Start.
Let's get to example number 2. The integration of tan cube x dx. If you want to solve this sum on your own, you can pause the video. If not, just continue watching. And maybe watch after you've solved. We can write tan cube x as tan square x multiplied by tan x. And we can as you know, the trigonometrical function sec square x minus tan square x is equal to 1. So we can substitute tan square x for sec square x minus 1. And it's multiplied with tan x dx. So we multiply tan x into the bracket. So what we have is tan x sec square x minus tan x dx. So now we split this into 2 parts from here. So what we have is tan x sec square x minus tan x dx. In this first integral, we can give it some names. Say we can call this entire integral I1. And let's call this entire integral I2. We already know the answer of I2 because in a previous video I had spoken on how to integrate tan x. So we already know the answer to I2. We'll integrate I1. It's a basic concept of substitution again. It's a very powerful tool of integration. I repeat that again and again. So we can write it as I1 is equal to tan x sec square x dx. We substitute tan x. We can take it as any variable again. Say z this time. Z. So sec square x, when we differentiate both the sides over here, tan x and z, we have sec square x dx is equal to dz. So we can substitute, so we have sec square x dx over here as well, sec square x dx. We can just substitute sec square x dx with dz and tan x with z, which gives us z dz, and the answer to this is simply z squared by 2 plus c. We put back tan x and we have tan square x divided by 2 plus c. So this is a separate part. Now I'm going to write the answer of this entire integral. We know the differential and integration of this. That's going to be like, we found the answer to be I2 I1 over here, tan square x by 2 plus c. So we just simply put in the value. And tan x, the integration of tan x is, it can be either log of sec x or the negative log of cos x. Since we have a negative sign here, we can just negate that with the predefined integral. Voila, the sum is done. You might notice that we have two c's over here. We can just ignore one and just write just one c instead of both. Tan square x by 2 plus log cos x plus c. I just wrote one c because we anyways do not know what c is. So it's an integration constant, but we do not know the value of the constant. So it's a variable to us. So we can just mention it once, it doesn't matter. It's the same. And here is the final sum that I'm going to demonstrate in this video. Cosec x divided by the log of tan x by 2 dx. There is seemingly no way to solve this sum at first glance, but when we think, we employ the use of substitution again over here. What do we substitute in this? I mean, how do we get to integrate this? How do we make it simpler? It might not look out to you, but we have to substitute the entire denominator. So the log of tan x by 2 is equal to e. When we differentiate both sides, what we have is 1 by the tan of x by 2 multiplied by the differentiation of tan x by 2, which is sec square x by 2 into half. So we have to simplify this now. This is equal to dt. Sorry, dx of this is equal to dt. Now we have to simplify this entire thing to hopefully get cosec x. We have to work with what we have. So tan x by 2. Tan x by 2 is sin x by 2 by cos x by 2. So the cos comes into the numerator while the sin stays in the denominator. And sec square x by 2 is 1 by cos square x by 2. So, and we have a 2 here, so we just put this 2 here. And cos square x by 2 dx is equal to dt. One of these, we have a cos x by 2 in the denominator and 2 cos x by 2 cos x by 2, which is cos square x by 2 in the denominator. So this square gets cancelled out with this numerator. What we have left is 1 by 2 sine x by 2 multiplied by cos x by 2. The denominator might now stand out to you. It's that formula. 2 sine x multiplied by cos x gives sine of 2x. So we use that here. Here the variable is x by 2. So multiply it by 2 and we have sine x. So 1 by sine x dx is equal to dt. So now we do have the numerator. This is cosec x dx is equal to dt. We substitute dt with the entire numerator and we put in t in place of the denominator. What we have left is a simple inverse integration. This gives us the log of the mod of t plus c. We put back in the value of t and we have the answer we're looking for, which is this. The log of tan x by 2 plus c. This is your answer. That's it for this video. Thanks for watching.